It's a symbol of immense power, a sprawling fortress that has housed the nerve center of American military might for decades. But the Pentagon is far more than just a building. It's a crucible, a place where decisions were forged and technologies conceived that didn't just shape warfare, but fundamentally reshaped the world we live in today. Think about it. When you look around your life, how much of it, how much of the very fabric of modern existence can you trace back to the halls of this iconic structure? The answer might surprise you. This is the story of how the Pentagon, in its relentless pursuit of national security and technological dominance, inadvertently built the modern world. Our story begins not with sleek computers or advanced weaponry, but with a stark and terrifying reality. The dawn of the nuclear age. The Second World War had ended, but a new, even more chilling conflict was brewing. The Cold War, a global struggle between two superpowers, the United States and the Soviet Union, locked in an ideological and existential battle. In this new world order, the stakes were higher than ever. The capacity for total annihilation loomed, and for the United States, the primary instrument of its defense, and increasingly its innovation, was the Department of Defense, headquartered in the newly constructed Pentagon. Opened in 1943, during the height of World War II, the Pentagon was an architectural marvel designed to consolidate the scattered offices of the War Department. But its true purpose, its destiny, was forged in the crucible of the Cold War. This wasn't just about fighting wars, it was about preventing them. And that meant being smarter, faster, and more technologically advanced than any potential adversary. The sheer scale of the Pentagon was a testament to the ambition of its mission. 5 sides, 5 floors, and an astonishing 3.7 million square feet of office space. It was built to house over 20,000 personnel, a city within a city, a command center for a nation at the forefront of a global ideological struggle. But the building itself was just the shell. The real power lay within its walls, in the minds of the brilliant scientists, engineers, and strategists who worked tirelessly to secure America's future. And their work, driven by the existential threat of nuclear war, would have unforeseen consequences for all of us. The Cold War wasn't just a military standoff. It was a race for technological supremacy. The Soviets had launched Sputnik, a small satellite that sent shockwaves through American society. It was a clear signal that the enemy was not just catching up, but potentially surpassing the United States in key scientific and technological areas. This was unacceptable. And so, the Pentagon, through its research and development agencies, became a powerful engine of innovation. Think about the Defense Advanced Research Projects Agency, or DARPA, as it's known today. It was born out of this Sputnik crisis, established in 1958. Its mandate was simple, yet audacious, to prevent technological surprise from happening again. DARPA's mission wasn't to develop incremental improvements, it was to foster revolutionary breakthroughs. They funded projects that were often considered too risky, too far-fetched, by traditional industry. They were looking for the game changers, the technologies that could fundamentally alter the balance of power. And what kind of projects did they fund? Well, some of them might sound familiar. Imagine a world before the internet, before email, before instant communication across vast distances. It's hard to picture, isn't it? But that was the reality for most of human history. The genesis of the internet, as we know it, can be traced back to the urgent need for resilient communication networks. In the event of a nuclear attack, how could the United States maintain command and control if its centralized communication systems were destroyed? This was a critical question, and the answer lay in a decentralized, robust network. This led to the development of ARPANET, the precursor to the Internet. It was a project funded by DARPA, designed to connect research institutions and allow for the sharing of information, even if parts of the network were disabled. It was a revolutionary concept. Instead of a single point of failure, information could find multiple paths to its destination. Think about the implications of that. A network that could withstand attack, a network that could connect people and ideas across vast distances. This wasn't just about military communication. It was about creating a new paradigm for information exchange. And it all started with a need born out of fear. The fear of nuclear annihilation. The fear of being outmaneuvered by the Soviet Union. The Pentagon, through DARPA, was essentially investing in a future where information flowed freely, securely, and reliably, no matter what. But the Internet was just one piece of the puzzle. The drive for technological superiority permeated every aspect of the Pentagon's research. Consider the miniaturization of electronics. The development of more powerful and efficient computing. These were essential for everything from missile guidance systems to code breaking. The demand for smaller, faster, and more reliable components spurred incredible advancements in semiconductor technology. Companies that would eventually become giants in the tech world received crucial early funding and research contracts from the Department of Defense. They were pushing the boundaries of what was possible, driven by the relentless demands of national security. This wasn't just about building better weapons. It was about building better brains for those weapons. It was about creating systems that could process information at unprecedented speeds, making complex calculations and decisions in fractions of a second. And these advancements didn't stay confined to military applications. The technologies developed for defense often found their way into the civilian sector, transforming industries and everyday life. The miniaturization of electronics, for example, paved the way for everything from portable radios to the personal computers that now sit on our desks and in our homes. Think about the sheer audacity of it. A government agency driven by the urgent imperatives of war and defense, becoming a de facto venture capital firm for groundbreaking technologies. They took risks that private industry often couldn't afford to take, funding research that might take years, even decades, to yield results. And the results, as we've seen, were profound. The Pentagon, in its quest to maintain American dominance, became an accidental architect of the information age. They didn't set out to build the Internet, or to revolutionize computing, or to create the foundations of the globalized economy. But their investments, their relentless pursuit of technological superiority, had precisely that effect. The Cold War was a period of intense competition, a zero-sum game where every perceived advantage was crucial. And in this environment, the Pentagon became a powerful catalyst for innovation. They funded research into areas that seemed like science fiction at the time, driven by the belief that anything was possible if the right minds were put to the task and the right resources were allocated. Consider the development of GPS, the Global Positioning System. Today, we use it for everything. Navigating our cars, tracking our fitness, even ordering food. It's so ubiquitous, so ingrained in our daily lives, it's hard to imagine a world without it. But GPS was not initially designed for consumer convenience. It was a military project developed to provide precise location and navigation for troops and assets in the field. The ability to know exactly where you were and where your allies and enemies were was a critical battlefield advantage. The system, which relies on a constellation of satellites orbiting the Earth, was a monumental undertaking. It required incredible advancements in satellite technology, in sophisticated computing, and in the precise timing mechanisms needed to triangulate positions. And who was funding this incredibly complex and expensive endeavor? The Pentagon. Their investment in GPS was driven by a clear strategic need. But as the technology matured, and as the Cold War began to thaw, the military realized the potential for broader applications. Eventually, GPS was made available for civilian use, and the impact was nothing short of revolutionary. It transformed logistics, agriculture, transportation, and countless other industries. It enabled new forms of commerce and communication. It literally changed the way we navigate our world. It's a classic example of how military innovation can have profound and far-reaching civilian benefits. The Pentagon, in its pursuit of strategic advantage, inadvertently created a technology that has become essential to the functioning of modern society. But the impact of the Pentagon's investment in innovation didn't stop with communication and navigation. Think about the materials science that was driven by the need for lighter, stronger, and more resilient materials for aircraft, spacecraft, and weaponry. These advancements have found their way into everything from high-performance sporting equipment to life-saving medical devices. The aerospace industry, in particular, owes a massive debt to Pentagon funding. The development of jet engines, for example, was heavily subsidized by military contracts. The race to build faster and more capable aircraft during the Cold War pushed the boundaries of engineering and manufacturing, leading to innovations that eventually benefited commercial aviation and made air travel accessible to the masses. It's a pattern that repeats itself again and again. The Pentagon identifies a need, a strategic imperative, and pours resources into finding a solution. And in the process of solving that problem, they often unlock a cascade of unforeseen innovations that ripple out into the civilian world, transforming industries, creating new markets, and fundamentally altering the way we live. So, when we talk about the Pentagon building the modern world, we're not just talking about weapons and warfare. We're talking about the infrastructure of information, the tools of navigation, the materials that shape our products, and the very engines that power our progress. The story of the Pentagon is a story of fear, yes, but it's also a story of incredible ingenuity. It's a testament to the power of focused investment and the unintended consequences of pursuing seemingly singular goals. The Cold War may be over, but the legacy of the Pentagon's investments in innovation continues to shape our lives in ways we might not even realize. The next time you use your smartphone, or book a flight, or even just look at a map, take a moment to consider the enduring influence of that sprawling fortress in Arlington, Virginia. It's a place that did more than just defend a nation. It helped build the world we inhabit today. The immense structure, a sprawling fortress of concrete and steel, designed to house a quarter of the U.S. military's personnel, was more than just an office building. It was a crucible, a nerve center forged in the fires of global conflict and tempered by the chilling winds of the Cold War. Its very existence was a testament to a nation's resolve, a physical manifestation of its military might. But the building itself was just the shell, the housing for the true engine of change that would soon begin to hum within its five-sided walls. The story of how the Pentagon built the modern world doesn't begin with a grand pronouncement or a singular, earth-shattering event. It unfolds, much like the technologies it would eventually spawn, through a series of calculated responses to perceived threats, a relentless pursuit of an edge. And the most significant of these threats, the one that truly galvanized the Pentagon's role as an unlikely architect of the future, arrived not in a tank or a bomber, but in a small, metallic sphere that orbited the Earth. Sputnik. The year was 1957. The Soviet Union, with its audacious launch, had not just sent a satellite into space, it had sent a shockwave through the American psyche. Suddenly, the technological superiority that the United States had long taken for granted seemed to be slipping away. The fear was palpable, a cold, creeping dread that settled over the nation. If the Soviets could put a satellite into orbit, what else could they do? Could they launch missiles that could reach American soil? The implications were terrifying, and for the Pentagon, they were unacceptable. This wasn't just about national pride, it was about survival. The space race was on, and it was inextricably linked to the arms race. The ability to launch objects into orbit meant the ability to deliver payloads, and in the context of the Cold War, that meant nuclear payloads. The Pentagon, already burdened with the immense responsibility of defending the nation, now faced an unprecedented challenge: how to regain the technological initiative and ensure America's security in this new, terrifying era. The response was swift and decisive. The launch of Sputnik didn't just spur the creation of NASA. It also led to the establishment of a new agency within the Department of Defense, an agency that would become the ultimate venture capital firm for revolutionary ideas, a place where seemingly impossible projects were not just considered, but actively pursued. This agency was the Defense Advanced Research Projects Agency, or DARPA, as it would come to be known. DARPA's mission wasn't to develop existing technologies. It was to create entirely new ones, to push the boundaries of what was thought possible, and to do so with a sense of urgency that bordered on desperation. The agency was designed to be agile, to cut through bureaucratic red tape, and to attract the brightest minds, offering them the resources and the freedom to explore radical concepts. It was a direct response to the Sputnik shock, a recognition that the traditional, incremental approach to defense research was no longer sufficient. The United States needed to leapfrog, not just catch up. Think about it. The entire edifice of modern technology, the very fabric of our interconnected lives, owes a significant debt to this period of intense fear and competitive innovation. DARPA, funded by the Pentagon's vast resources and driven by the existential threat of nuclear war, became an engine of discovery, a place where the seeds of technologies we now take for granted were sown. And what kind of projects did they fund? They weren't just focused on faster planes or bigger bombs. The nature of the threat demanded a more profound shift. The fear of a single, devastating nuclear strike, capable of crippling command and control systems, meant that communication networks had to be resilient. They had to be able to withstand attack, to reroute information around damaged nodes, to keep functioning even if parts of the network were destroyed. This was the genesis of a concept that would fundamentally alter human interaction: a decentralized, robust communication system. This wasn't about simply building more telephone lines. This was about a paradigm shift in how information could flow. Imagine the challenge. How do you create a network that can survive a nuclear attack? How do you ensure that vital communications can continue when critical infrastructure might be obliterated? The answer, which seemed almost like science fiction at the time, lay in packet switching. Instead of a dedicated, continuous connection between 2 points, data would be broken down into small packets, each with its own address. These packets would then travel independently through the network, finding the best available path and reassembling at their destination. If one path was destroyed, the packets could simply find another. This audacious idea, born out of the chilling calculus of nuclear war, would eventually evolve into the Internet. Yes, the very same Internet that connects billions of people around the globe, that powers our economies, our social lives, and our access to information, has roots in a Pentagon initiative designed to safeguard military communications during the Cold War. It's a remarkable, almost ironic twist of fate. The instrument of potential destruction, the very thing that fueled the need for innovation, ultimately gave birth to the most powerful tool for connection and dissemination of knowledge the world has ever known. But the Pentagon's influence didn't stop there. The need for precise navigation, particularly for military operations in a world where precise targeting was paramount, also drove significant technological advancements. Think about the challenges of navigating vast oceans, dense jungles, or even the unforgiving vacuum of space without reliable points of reference. Traditional methods, relying on celestial bodies or ground-based beacons, had their limitations, especially in adverse weather or in areas with limited infrastructure. The idea of a global positioning system, a network of satellites that could provide precise location data to anyone with a receiver, began to take shape. The concept was revolutionary: a constellation of satellites orbiting the Earth, broadcasting signals that could be used to triangulate a user's position anywhere on the planet, at any time, in any weather. This was a massive undertaking, requiring advancements in satellite technology, atomic clock precision, and sophisticated mathematical algorithms. And who was funding this ambitious endeavor? Once again, it was the Pentagon, driven by the need for superior military capabilities, the ability to guide missiles with pinpoint accuracy, to navigate aircraft and ships with unprecedented precision, and to coordinate complex military movements across vast distances was a strategic imperative. The development of what would become the Global Positioning System, or GPS, was a direct consequence of the Cold War arms race and the Pentagon's relentless pursuit of technological dominance. It's hard to picture, isn't it? That the little device in your pocket, the one that guides you through unfamiliar streets, that helps you order a pizza, that tracks your morning run, owes its existence to the same defense establishment that was grappling with the threat of global annihilation. The military requirements were the initial catalyst, the immense funding and the unwavering commitment to solving these complex problems, fueled by the specter of war, that made these groundbreaking technologies a reality. The Pentagon, in its role as the ultimate patron of cutting-edge research and development, became an unlikely incubator for the digital age. It funded the fundamental research, took the immense risks, and persevered through the inevitable setbacks. The scientists and engineers who worked under its auspices, driven by a sense of patriotic duty and a passion for discovery, laid the groundwork for innovations that would ripple outwards, transforming not just the battlefield, but every aspect of civilian life. They were building the infrastructure of the future, brick by digital brick, packet by packet, satellite by satellite, all under the watchful eye of the sprawling fortress in Arlington. The Cold War ended. Its ideological